So that was the things to think about sort of statistical and gaining statistical significance, and the key one was how many animals. Another thing is you get to the end of your study, you want to be able to generalise your results. So I suppose at the start you want to think about, well, I'm just doing this study in the Roslin Institute, and can it be generalised elsewhere? And other things you might think about are, do I just want to generalise to one species or to all species or all types of animal? Do I want to generalise to just different environments? Would my study be applicable in certain types of different environments? So when you think about generalisability, the question is what to sample. For example, if you've got cages of animals or different farms even, it's possible that the measurements are going to be correlated, and it might be that your sampling unit is the cage rather than the animal. It might be you've got different litters and you might want to sample the litter rather than the individuals within the litter. Although a lot of the time, if you're looking at animals, the sampling unit will be the animal. But it's important that the units you sample on are independent of each other. When you set up your study, once you've decided on your sampling unit, that might be, say, cage or animal, then you allocate the interventions to those sampling units. Just thinking about generalisability, if you imagine a study of hen housing where you're studying whether factory or free-range sort of housing of hens is preferable for some measure of egg production. If you just took one farm, say farm A and farm B, and took a huge number of hens on those farms, you might find, yes, farm A gives different results to farm B, but it might be completely related to the factors around that individual farm. The farms might be run very differently. So you really need to take multiple examples of the farms as well as the hens at each farm. So, and in this case, the sampling unit would be the farms, not the hens. You want to sort of allocate the farms to the type of housing rather than sort of assume that you can sort of allocate a certain number of hens and just have them in one farm. To generalise to several farms, you need to do that, have several different farms having each type of housing. Another example, thinking about generalisability, this is quite a dated one, I'm afraid. It was taken by a presentation by somebody else that talks about experimental design in the university, Nick Colgrave, but I think it's sort of quite a nice example. So he came up with an example of sort of asking chimps smarter than humans, how can we assess this? And that you might think about devising a test where you test how smart they are on a range of kind of 0 to 10. So if you do one test on this chimp and another test on, here we've got George Bush, and you get a score for each of them, you can't conclude that much just from that test. Certainly you can't conclude much about the particular chimp and George Bush, and you can't conclude much about humans and chimps either. So you might think, well, if I take several examples of George Bush and this chimp on different occasions, and yeah, I didn't do this, but I thought it was a nice slide, and they have different scores on each occasion, so there's a bit of variability in the scores, and take the average, so you've replicated your samples, and you might think, well, that's enough to prove what I want to. Charles the chimp scores an average of 6.2, and then Bush scores an average of 6.8, and we've taken so many samples that we find that statistically significant. So we can conclude, all we can conclude is that this chimp, George, is dumber than this human, George Bush. But that's not enough. We can't conclude that chimps are dumber than humans. So of course we need to go on and measure a set of different chimps and different humans. So we need to be sure what we're going to replicate on. And sometimes it's fairly obvious, I think it is in this case, but not always.